What up, athletes? Whoop, whoop. All right, let's do this today. This is 9.4, and honestly, I think you guys are going to crush through it. We're just going to go through a couple examples, be a real short video. This is solving systems of equations by graphing, and here's the deal. Solutions to systems of equations come in one of three flavors. There is either going to be one solution, infinite solutions, or no solution. And what do those three look like? Well, one solution means that we have two lines that cross once. That's what the solution is. You're finding out, I should probably zoom in, you're finding out where these lines cross, right? So that's one solution. If we have infinite solutions because we have a line and then a second line that lies right on top of it. So it's the same line, right? That's infinite solution. No solution means we have two lines that are parallel to each other. And remember, if they're parallel, they have the same slope, different start points, and they'll never cross. Okay? So that would be no solution. All right? So we're going to graph these, and I'm going to show you, just give you some advice on how to do these. So again, take the sign in front of it. This is our y-intercept, right? So I know I start at -4. And my slope tells me, remember I can always put it over 1. It tells me to go up 1, 2, 3 over 1. And I'm actually going to do that a couple times. 1, 2, 3 over 1. Even if you don't normally, I would recommend doing it. Number one, it helps you do a more accurate line. But also, my pen, it smears. When we're specifically graphing to find a solution, it's going to help us find points where they cross. So this one has a start value of 2 and a slope of -3, so that's down 1, 2, 3 over 1. See how right away I know that that line's crossing right there, and then I can go down 3 over 1. I do that specifically so I can stair-step myself to a solution. And then let's go ahead and write our solution on here. That is the point what? 1, -1. And that is how we're going to solve by graphing. Now, I'd like to do one that's a little more, got a little more to it. So, trying to look for a specific. I think I actually want to do this one right here because it's a little bit more tough. When you get to ones like this, so this one says, all right, we have a start value of -2. All right, -2, boom. And it's up 1, 2, 3, 4, 5 over 1, 2, 3, 4. There we go. And this one has a start. And notice I can only do one dot because I just don't have enough room anywhere else. We've got our first line. Now our second line, start value of -1. Same slope. What do we know if it's the same slope, different start value? These are going to be parallel. So that's up 1, 2, 3, 4, 5, 2, 3, 4. So I can tell you right off the bat, this is going to be a no solution. See? You draw it as best you can, but they're going to be parallel. No solution. Okay? Let's just try one more from the back just to really get our feet wet behind us. All right, there we go. Let's see. This is a start value of -3. And it says to go down 3 over 2. Notice I can't go down 3 because I always like to go down when it's negative. But if you can't go down 3 over 2, I can go up 1, 2, 3, and back 2. All right? 1, 2, 3, back 2. So that's how you deal with not being able to proceed the typical way. And let's go ahead and graph the last one. Start value of 1, -1/2 slope, so that's down 1 over 2. But you know what? I want to know where I connect over here. So I'm actually going to go up 1, back 2, up 1, back. See how I connect right there? And I can see that. So I like to stair-step myself when graphing. Again, you don't have to, but it helps because we're not perfect at graphing. And what is my point right there? That's the solution. It's going to be -4, +3 is the solution, okay? All right, so that's what we're doing today. Go ahead and solve all these systems by graphing. With that said, peace out.